Hello there. Let's do a quick video on some unconventional network environments that you will possibly get some questions about in the Network Plus exam. First up, let's tackle IoT, or the Internet of Things. Now, IoT devices are usually going to be falling into one of the following categories. First of all, you get consumer IoT devices. These will be things like your smartwatch, your smartphone, your tablet, stuff like that, as well as smart appliances, smart TV, smart washing machine, smart whatever you've got nowadays. Then you also get the healthcare devices now, which will normally be some sort of wearable health monitor, a bit more than your smartwatch keeping track of your heart rate. This will be things like people who need to wear a diabetic monitor, and can also provide remote patient monitoring in some cases. You also get some industrial IoT devices as well. These will normally be sensors to control the machines and a variety of other things. Then you get agricultural, which will be things like soil moisture sensors, drones, and stuff that helps the farmers keep track and monitor their livestock. Now, one of the common threads between all of these devices is they are not standard computing devices. They're normally going to have some sort of microcomputer built into them, and they will have minimal local processing capability beyond what they're designed to do. But what makes IoT devices special is they're using TCP/IP for their communication services. This includes the industrial IoT devices. Now, in terms of IoT connectivity, they can get their connectivity through a variety of common network standards and some that were developed specifically for this space. Let's start out with Ethernet, which means that you can probably expect to see this on a twisted pair cable or possibly a fiber optic cable that supports the Ethernet standard. You also get very common for them is Wi-Fi, especially on the consumer side of things. Bluetooth is also pretty popular as well for the smart devices and some of the wearables. But due to Bluetooth's limited range, obviously that does decrease some of its implementation options. In that case, cellular might be a better option. And then we get Z-Wave and Zigbee, which were both specifically built for IoT type communications and are competitors to Bluetooth and Wi-Fi in this space. Now, in terms of IoT devices, they do need to be controlled. Usually this will come in the form of an IoT Control hub, which may be vendor proprietary, where you have to buy into that vendor's ecosystem, their IoT products, their IoT Control hub. Or you can go third party, in which case then you want to have a close look at, does the IoT Control hub use a closed source development model or an open source development model? In general, closed source will probably work better, but the future and longevity of such a development model in this space is not guaranteed. I have seen many IoT vendors come and go over the years, promising to change the world and failing to do so and then going out of business, leaving their customers high and dry when it comes to support. The open source side of things, a little bit better because at least the open source community can pick up and carry on with that software. In fairness though, I am a big open source advocate. Then you also get app-controlled IoT devices, where it will be an app on your smartphone or tablet that controls the IoT products. This will usually be a closed source model, and its capabilities, security, and upgrade process will be questionable at best. Now, the big pain point, and the reason why CompTIA wants you to know a bit about IoT, is because it does introduce some interesting challenges when it comes to network security. So let's look at those challenges. First of all, this is definitely going to increase the attack surface in your network because you've got a bunch of new devices running services that are not fully open and clear to you what they are and how they're designed. These devices also usually have very weak security capabilities, but in their fairness, they don't have the best processes built into them, and that does limit their ability to do advanced levels of cryptography. And again, the update cycles aren't always great. Some of the better known brands, who are not getting free advertising from me, will keep their stuff up to date, but for only as long as it's profitable to do so. Newer entrants into the IoT market space might not do much in terms of updating, and then the no-name rebrands that you get from various places, there might not be any updates at all. So the mitigation strategies to try and deal with these security issues involve minimizing their use within an organization. My advice and approach to this is the benefit of using an IoT appliance or device must significantly outweigh the risks. There must be a major reason for having this, beyond, ooh, we're using this, it's cool. There needs to be some sort of benefit to this. And then, when you do deploy an IoT device within your organization, you want to look at segmentation of your network. Consider doing dedicated network infrastructure. If that's not possible, you can at least map the Wi-Fi SSID that you use for your IoT devices to its own dedicated discrete VLAN. But preferably, physically separate infrastructure would probably work best here. And then, apply what updates you do get your hands on. Obviously, use a bit of patch management practices where you try and test this out before you roll it out, because the update might cause you and your organization a problem. And then do regular auditing to go and check to see that there are no rogue IoT devices, and throw some occasional pen testing at this if you can, mainly to see if the IoT devices can be used as a pivoting point to get into the rest of your normal production network. Then we get to the more interesting and involved kinds of things: embedded systems and industrial control systems. Now, for these, the devices are a bit more interesting. They are usually embedded into an appliance or some sort of big machine, and it's often a very built-to-purpose computer system. Normally, it's a custom-designed computer, or it's a programmable logic controller or PLC, or possibly an FPGA or field programmable array chip. Usually, these have significant industrial applications, such as air traffic control, full-on industrial control systems for power plants, mines, and so forth. Speaking of power generation, pharmaceutical production, the list goes on. But usually this will be a very serious kind of industrial implementation, more so than what IoT would be used for. And these embedded computers will either run a real-time operating system that is purpose-built for this task, or some sort of graphical programming language like ladder logic that is used on PLCs. Now, these industrial control systems usually communicate with a variety of interesting standards and protocols, such as Modbus, DNP3, Siemens S7 comms, Industrial Ethernet, which is not the same as normal Ethernet, CAN bus, and a bunch more. Now, the good news is you don't need to know these in depth for Network Plus, you just need to know of them. And in the workplace, you might not even come across these unless you're working at some sort of industrial place. But collectively, we refer to these communication services as OT, or Operational Technology Networks, as they are essential to an industrial operation and not standard TCP/IP Ethernet networking paradigms. Now, in terms of the communication, oftentimes they'll be implemented at an industrial site, and you'll have an industrial control system that coordinates the machinery and equipment at these places, and that will be your operational technology network, or your OT network. Now, some larger industrial organizations might actually have this running across multiple sites. So let's make that site A and introduce a couple of extras. An organization might want to run a monitoring solution, possibly even a control solution from headquarters, and that is called a SCADA system, supervisory control and data acquisition. Now, in terms of communicating and connecting these together, you'd probably have to use a more ordinary TCP/IP connection with some sort of WAN link. Now, this can be a bit of a challenge, but as long as this machine is able to apply good normal network security, you can do quite a bit to keep the OT network shielded from the threats of the internet. Also, you could look at maybe a more privatized WAN connection to make this a bit safer. But we're running ahead of ourselves. Let's do the network security section nicely. So the challenges are as follows. It can be hard to discover the vulnerabilities on these systems, as most vulnerability databases and scanning tools do not necessarily have the right signatures and definitions in them to pick up on these vulnerabilities. Also, these systems might have little to no security designed into them. These systems are usually built by industrial engineers who are not necessarily very IT savvy. That ladder logic language I told you about earlier, it was designed for industrial engineers who have very little to no programming experience to be able to program the logic controllers for those industrial machines. And don't get me wrong, those industrial engineers, they're very smart people. I've got a couple friends that are in that space, but that doesn't mean they're going to be able to handle IT security threats like you or I could. Also, speaking of those industrial engineers, the updates are dependent on them in some cases, which means that if that industrial engineer stops working on that project or for that organization, there might not be any big updates coming for a while from there. So that could be quite a significant issue. And there are going to be massive consequences for the environment and or human safety and lives if these things go wrong. So there is a lot on the line here. So some mitigation strategies you can look at doing. Segmentation, shock and horror, that's an obvious go-to option. Again, dedicated infrastructure would be a good idea, but in an extreme solution, you might want to consider air gapping, where there is nothing between the OT network and the rest of your normal network apart from the air in between. And no, I'm not including Wi-Fi signals here. Literally, there is no connectivity to that kind of network. That level of isolation could help keep the remote threats to a minimum and rely on physical security at the site to prevent any sort of on-premises internal threat actors from gaining access. You should also consider at least minimizing on remote control capabilities. If you're going to do a SCADA system, that's fine for remote monitoring. But remote control, is that going to be absolutely necessary? If so, okay, cool. Let's work out how we can do it safely and securely, or at least as safely and securely as we can. But if we don't need that remote control capability, stick to remote monitoring then. It'll be a lot better. Then, audit the operational technology networks as best you can. There are pen testers and security specialists starting to move into the space, which is a good thing. And utilize security analytics to your advantage. But when you do try and do security analysis on OT networks, you want to make sure it's a passive analysis and enumeration rather than some sort of active testing technique that could lead to some unexpected outcome or occurrence that could lead to a possible industrial disaster. And try to keep yourself abreast of the changes and improvements in the sector. It's taken a long time, but at long last, we are starting to see major IT security focus in this space, especially as cyber warfare and digital terrorism is starting to become a thing and becoming way more significant. More attention is being paid to the space in our computerization of everything. But for Network Plus, that is all you need to know. All CompTIA really expects of you is you to be aware of this, so that if you do start getting moved into the space, or you do decide to move into the space, you're a bit more prepared for it. It is going to require collaboration between the IT professionals like you and me, and the people that design these fancy cool systems. Nonetheless though, I'd like to say thank you for watching. I really appreciate it. And if you have any friends, family members, colleagues, peers, etc. who would be interested in Network Plus, don't be afraid to share this video with them. Otherwise though, I'll catch you in the next video.